Hi guys, so here is the video for the answers to defining a geometric plane extension. So the first one says, what do the feet of a three-legged stool represent? So think about if you have a stool, so here's your stool, and then it's got three legs, and then this one's kind of heading out here. Okay, so each one of these legs represents a point. So if you have 3 points, remember that means that you can take any two of those points. So these 2 points right here are on one line, and this third point is not on the line, so therefore they represent a plane. Okay, remember any 3 non-collinear points, so 3 non-collinear points define a plane. Okay, that's a really important concept in geometry. Alright, so number 2 is saying, why do you think that a four-legged stool would wobble on a flat surface? So I want you to think about it. So if we have our stool, keep on doing the erasing. If we have our stool, so here's our stool, and then here's leg 1, leg 2, leg 3 back here, and leg 4 back there. Okay, so I want you to think about it. Let's say that on our four-legged stool, so here's our point, so here's the line, right, because here's 1 point here and 1 point there. When you have that stool, if these 2 legs right here are not, so if this leg right there and this leg right there are not the same length, what's going to happen? What's going to happen is that it's going to rest in one of these points right here. So this one, okay, come on now. Sorry guys. This point right here is going to rest, and this fourth leg right here might be sitting up. So basically what that means is that if you have 4 points, they're not necessarily coplanar unless they are intersecting lines. Okay, so I just want you to think about the three-legged stool thing. Okay, all right. So let's talk about number 3. All right, it says, are E, B, and D coplanar? So we've got E, B, and D, right? Those are coplanar because, right, these 2 lines, or 2 points, are collinear, and then we have a third point that is not on that line. So therefore this is, yes, it is coplanar because you have 3 non-collinear points. And remember, that means that all 3 of them are not collinear. Okay? So 2 of them are, because they always will be, and then the B is what defines the second part of that plane. Okay? Alright, number 4. So 4 says, is E, B, and F coplanar? Now when you look at the picture, it looks like because F is all the way down here, right, so F is all the way down here, that it's not coplanar. However, these 2 points define a line, and our third point right here is not on that line. So technically they are coplanar, it's just not showing it on the picture. Okay, any 3 points, as long as they are not on the same line, are coplanar. So the answer to this one would be yes as well. Alright, number 5. So we've got F, A, E, and B. And it's asking you if they're coplanar. So I want you to think about something. In order to be something to be coplanar, it has to be 2 points that are collinear and 1 point that is not on that line. So therefore that means that A, E, and B are on the same plane, right? Because A and D are on the same line and then B is not. But look at F. There's no way that it could be coplanar. Okay, so this one is no. Okay, 4 points are not necessarily going to be coplanar. They can be, and we'll talk about why that is, but in this instance they're not, because those 3 points define this plane right here, and F is down here at the bottom. Okay, so that one is no. Alright, so let's see, we are on number 6. So number 6 wants to know if F, A, E, and D are coplanar. Okay, here's an example of where we have 4 points. But these 3 points right here, okay, these 3 points, A, E, and D, are all on the same line. Okay, so they've created the line, so really you only need 2 points to make a line. Since all 3 of them are on the line, this 4th point right here makes it coplanar. Okay, don't let the drawing confuse you, okay, because the drawing is just specifying one single plane, but you could define a plane that goes through that line and then through that point. Okay, so this one would be yes. All right, number 7, are AD and CB coplanar? So AD is right here. Okay, and then we have CB, which is right here. Okay, so you can look at it 2 different ways. You've got 2 points, so you have point A and point D are collinear, and then there is a 3rd point, point C, that is not on that line, okay? So that is coplanar, and because B is on the same line as C, you can kind of see that if you have 2 intersecting lines right here, then that means that they are coplanar. So this rule, what I would write down is 2 intersecting lines are always coplanar. Okay? All right. So now we are on to number 8. So 8 says EB, which is this line right here, and FD. So FD is this line right here. Okay. Now, technically, if it's going through F, which is all the way down here, okay, it's actually not going to intersect with this line, so therefore they are not coplanar, because if you're looking at this, this one's actually going across this way, and since this one right here, the FD is kind of angled up, they're actually skew lines, so therefore they are not going to intersect, so those 2 lines together are not coplanar, so number 8 is no. All right, number 9. So number 9 says are FE, so here is FE, and EC coplanar. Okay, so what do you think about that one? FE is going straight up and down, okay, and this one is going across the plane, so these are actually perpendicular to each other right there. Okay, if they are perpendicular, they are not on the same plane. Okay, so this one is no, they are not coplanar because they are perpendicular to each other. Okay? All right, and then number 10, this one should be fairly easy. Write a fraction less than 1 that has a prime number numerator and a prime number denominator. So your prime numbers are 2, 3, 5. I mean, you can write as many as you want. And if you want to be less than 1, the smaller number has to be on top. So you could write 2/3. It could be 5/7. It could be 7/11. Right? As long as these 2 numbers are prime and the smallest number is on top. Okay. Here we go. All right. This one says find the intersection of CG. So CG is this line right here, and CD, so CD is right here, and where they intersect is right here at point C. Right? Remember, 2 lines always intersect at exactly 1 point. 2 lines intersect in exactly is an important word, 1 point. Okay? All right. number 12. So find the intersections of plane ACG. So ACG is going to be, so here's A, here's C and G. So here's plane ACG. And then let's do the other plane is CDB. So here is CDB. So you know it's going to be this one right here. Okay, where they overlap is this right here. Okay, so they intersect at line CA, or you can also write line AC. Okay, two planes always intersect at a line. Okay, always, no matter what. Okay? All right. So this one says, find the intersections of plane ACG. So again, that's this one, ACG, and CDB. So, or sorry, GDB. So GDB, if you guys notice, this one's kind of different. It's like you have to draw it in. So here's CDB. So really that plane goes like this. Okay, you see that? So here's your plane right here. So it intersects right here in line GE or line EG. Okay, and the reason why is because two planes always intersect at a line. All right, number 13 says find the intersection of plane ACG. So ACG is this plane. Okay, so line ACG and line AB. So AB is right here. Okay, so when a line goes through a plane, okay, it can intersect in two ways, but in this case, it's going through the plane, so it intersects at a point, and that intersection point is point A, okay, because it's going straight through it. Okay, it's kind of like if I draw a perpendicular line, like going up through the plane like this. Oh, that's a horrible drawing, sorry guys. Right, so if it's coming through and it's intersecting there and then leaving there, right, it's intersecting at this point right there. So think about it, if you're shooting a bullet in some plexiglass or something, it's going straight through the plane and it's intersecting at that point. So it would be point A. All right, 14. Name the fourth point on CGH. So we have CGH, so you kind of have part of the rectangle. So the rest of it is going to go through point D. So that one would be point D. Okay? All right. Number 15. Are points C and F collinear? So we've got C over here, and we've got F over there. Now they're not on the line as far as the drawing is concerned, but they are collinear because any 2 points are always collinear because it takes 2 points to make a line. Okay? All right, CA and GE. So CA and GE. Okay, they are equidistant to each other, so that means that line CA is parallel to line GE. Okay, they are parallel to each other. That one should be pretty easy. All right, here we go. CA. So CA is right here. And then EF. So EF is down here. All right, so they are not parallel, and they will not intersect, and they do not lie on the same plane, so therefore they are skew lines. So not parallel, do not intersect, and on different planes. That means that they're skew. Okay, so let's just review. All right, so we have got number, what are we on? 17. All right, 17. A plane is determined by two intersecting lines. That is true. Okay, because if I have got this line here, and it intersects with this line here, and I've got points A, B, C, and D. Remember, it takes 3 points to make a plane. 2 points that are collinear and 1 that is not. So this satisfies it because A and B are collinear and D is off the line. Or you could use D, and since D and C are on the same line, that means that all 4 points are determine a plane. So that one is true. All right, so this one says if 3 points are coplanar, then they are collinear. That is false. Okay, because if they are coplanar, they don't necessarily have to be collinear because I've got my 2 here, and then that third one makes my plane, so therefore they are not collinear, so that one would be false. Alright, number 19, any 2 points are collinear. That one is true because if I draw point A and point B, that makes a line. I missed that one. If I draw point D and point C, those two make a line. Okay? That one should be pretty easy. Alright, 20. A plane and a line intersect at most 1 point. Okay, that word most is giving it away because that means that no more than 1 point. So that one is actually false, and I'm going to tell you why. Okay, so if I have my plane right here, okay, and I'm going to have a line that intersects it. If the line goes through it like this, okay, it intersects at this point right there. Oops. Right, it intersects there. So it does intersect at a point, but there's another way that a line can intersect a plane. So let's say I've got my plane here. Okay, the line could also go like this. So if it's going through the plane that way, then it actually intersects on the line itself. Okay, so if it's looking like this, it intersects at a point. If it looks like this, then it intersects infinitely because it's following along the same path of the plane, if that makes sense. All right, 21. 3 points are not always coplanar. Okay, 3 points are not always coplanar. All right, what do we think about that one? Okay, that would actually be true. Okay, 3 points don't always define a plane because if you've got 3 points on the same line, they're going to be coplanar because they're going to be on the same plane, obviously, but it doesn't define the plane. Okay, so 3 points are not always coplanar. Actually, sorry, that's false. Sorry, guys, I read it wrong. Because 3 points are always coplanar no matter what. Either the 3 points define the plane or the 3 points lie in the same plane. All right. Number 22. 2 planes intersect in infinitely many points. That's true because if you have this plane, it's going to be hard for me to draw this. Let's just do like this. Intersecting with this plane, remember it intersects at a line, and a line is an infinite amount of points, so that one is true. Okay, and this one says a line lies in one and only one plane. That is actually false because think about the box. Okay, so if I have that prism, this line right here lies in two planes. It lies in this plane, and it also lies in that plane. Okay, so that one is false. All right, and number 24, a line and a point not on that line only in one and only one plane. So we have a line and a point not on the line, and that lies in one and only one plane. That would be true, because the line could lie in more than one plane, right? But the point can only be in one plane at a time. Okay? All right. I hope that made sense. It's my first video of the year, so I know it was a little long. Anyways, you guys have a good night, and I will see you tomorrow.